Okay guys, welcome back. Today we are going to solve for Algebra 2 Semester 2 exponential functions. Let's begin. So the first question is, if the parent function is y equals 3 to the power of x, which is the function of the graph, this graph. Now we know that the parent function is 3 to the power of x. The easiest way to do it is to check, first of all, it's going down. As you can see, it's going down. The graph is going down, which means, let me do this thing. Which means if we have the exponential function is y equals a times b to the power of x, this is the exponential function, of course, it means that a is supposed to be negative. It needs to be negative. Why negative? Negative because it's going down, okay? So, for example, the first choice is y equals 2 times 3 to the power of x. A is 2 and 2 is not negative, so this one is for sure not an answer. That's why A has to be negative. So if we go down now, we have only two choices that are negative. It's the second one and the third one. Now we need to know which one is the correct one. Now to know this one, we need to find a point and see which one of these gives us the correct y value. So let's say if we have the 1, okay, the negative 1. Let's take the negative 1. The negative 1, the y value, the negative y, maybe I can, yeah, perfect. So it's either the second or the third one. The negative 1, as you can see, is the negative 1. The y value for negative 1 is how much? It's about negative 1. It's about negative 1, negative something like that, negative 3. I can see about negative 1. It's not accurate. So we need to check which one gives us the closest y. So if we go, for example, check this one. Y equals negative 2 times 3 to the power of x. So we decided that the x value is negative 1. So it's going to be y equals negative 2 times 3 to the power of negative 1. So in this case, the answer will be negative 2/3. Okay? Negative 2/3. It could be negative 2/3 because it's close to negative 1. So it could be negative 1/2, negative 2/3. Let's check the second one without writing. Let's plug in 1. 3 to the power of negative 1 is negative 1/3. Times negative 1/2 is going to be negative 1/6. Negative 1/6. So negative 1/6 is going to be a little bit higher. It's smaller than negative. It's smaller than negative 2/3. So that's why I would go, the more accurate answer would be the negative 2 times 3 to the power of x. That's the answer. So all you need to do is check the point. So the answer would be this one. Question 2, of course, the same thing. Which is the graph of the function y equals 3 to the power of x? Y equals 3 to the power of x. Which one do you think? Can I zoom it this way? Yeah, I can zoom it. I hope you can see it. So if you can see it like that, I hope you can see it better. So the same thing, guys. Which one do you think? 3 to the power of x. So 3 to the power of x, because it's positive, the a is 1 in this case, because 1 times 3 to the power of x. Because it's positive, and 3 is the b. It means that it's going up. So this one is going down, which is wrong. This one is also going down, which is, of course, you look at the graph from left to right. And this one is going up, and this one is going up. So it's either the third or the fourth one. Now we need to check. So for example, let me check. That's 1. Yes. So let's check for 1. Let's plug in 1, okay? Let's plug in 1 and see which one is closer to that answer. This one or this one? As you can see, In this case, in this case, 1 is about 3. If you go straight up, it connects the graph with 3. In this case, 1 is about 2. So let's say which one is the correct answer. You need to plug in the number here. Of course, we need to plug in 1. 3 to the power of 1 is how much? 3. So the graph with the answer of 3 is the answer. So this one is 1, this one is 2, and this one is 3. So this is the answer. As you can see, 1, if you go straight up, it comes to 3. Use the graph of y equals a to the power of x to evaluate the expression e to the power of negative 1.5. Now this one, guys, it's easy. How much is the value of x? The value of x is negative 1.5. So we need to go to the graph and look for the x. And the x is negative 1.5. So this one would be negative 1. Can you see it? This one would be negative 1 before the negative 2. And a half more. So it's going to be about less than 1. So this is 1. It's going to be less than 1. So it's going to be between 0 and 1. Between 0 and 1. So let's see which one has between 0 and 1. As you can see, we have two answers. We have between 0 and 1. We have the 0.6 and the 0.2. Now we need to check which one do you think it is. Is it 0.6 or 0.2? Now because the point is here, we're talking about negative 1.5. So this is negative 1, and this is negative 1.5. As you can see, it's really close. It's really close, which means it's the lowest. It's not going to be negative 0.06 because negative 0.06 is higher than 1.5. So it's going to be around here. So the answer would be 0.2. The answer would be 0.2. Which is the graph of the function y equals negative 4 to the power of x? Again, guys, negative 4, it means that the graph is going downwards. So in this case, because the graph is going, so it could be the first graph, the second no, the third is no, or the fourth. So the third or the fourth. As you can see, both of them has the y-intercept of negative 1 here and also negative 1. So I need to choose a different point. Let's say, for example, the point 1. Let's plug in 1 and see the answer. In this case, the 1 is about negative 3. Let's see if it's correct, this one. So negative 4 to the power of 1 is negative 4. So this one is about negative 3. So maybe this one will be better. If we come look at this one, let's go down. Negative 1, if you go straight, it's negative 4. So the answer is the last one. Which is the asymptote of the graph? Now, the asymptote is a line, okay? A line where the graph keeps on getting close to, but it never intersects. So in this case, as you can see, we have the options y equals 0, y equals negative 1, y equals 1, and y equals 2. So if you want to graph them, like we have y equals 0, this is y equals 0, the one on the 0, this is the 0. So as you can see, the graph crosses this line, so it's not an asymptote. If we go to y equals negative 1, y equals negative 1 is here. So the graph also crosses this line. So it's not an answer. Y equals 1, it's here. As you can see, y equals 1, the graph keeps on getting close to y equals 1, but it never crosses it. So that's why the asymptote would be y equals 1. Okay? And y equals 2, it's too high. It never crosses it, but the graph keeps on getting closer to y equals 1. The same thing here, guys, here. We have e to the power of negative 2.8, okay? I hope you can see it. So negative 2.8, it's about here in the middle, really close. As you can see, it's really close to a 0. oh, come on. It's really close to a 0. As you can see, that's negative 2, and he wants negative 2.8. So that's negative 2.5 in the middle. And no, that's going to be negative 3, so it's going to be really close here. So as you can see, the line of the graph is really close to a 0. So the closest one to a 0 would be the answer, and it has to be positive. So the only one that's closer to the 0 is 0.1. Negative 0.1 is negative, but it's supposed to be positive because it's above the x-axis. Now we have a word problem. Can we, if we go like that, solution. Okay, I can zoom to this part. I don't like it, but we'll see. So we have suppose you invest $950 at an annual interest rate of 6.5% compounding continuously. How much will you have in the account after 10 years? So in this case, you need to use a formula. The formula is A, okay, equals P times E to the power of R times T, okay? A is the amount that you're gonna have after specific time. So A stays the same, okay? That's for A. P is the principal, how much money you have now, or what is the amount now, or what is the value now. In this case, the value now, how much he invests? $950. Times E is a number, okay? 2 point something. R is the rate. The rate is 6.5%. Times T, it's the time in years, which is in this case after 10 years. So all you need to do is plug in the calculator. So it's going to be 950 times E to the power of 6.5% times 10, and the answer is 1819.7. 1819.7, and as you can see, the closest to it is 1820, and this will be your answer. That is it. All you need to do is plug in the numbers. Now let's go to the next one. The same question, I will solve it, and this will be it for today. So let me zoom it first. Okay, so we have let me see. Suppose you invest $400 at an annual interest rate of 7.6% compounding continuously. How much will you have in the account after 1.5 years? So after a year and a half. So it means the same thing, guys. When you have compounding continuously, you use this formula. A equals P times E to the power of RT. A is the amount, how much money we are going to have. The P is the principal, which is $400 in this case. E to the power of R. R is the rate, which is 7.6%, times T is how many years? Times 1.5. So now we're going to do the same thing. 400 times E, 7.6 times 1.5. The answer is 448.3. So the amount will be is 448.3. So after a year and a half, I'm gonna earn about $48. That is it. Okay, that's it for today, guys. Have a great day. Be safe.